You may have sold water conditioning products all your life, but have never seen how these products are actually made. Today we're going to show you how the Canature fiberglass pressure tank is made, and tell you why it's the most impressive and reliable tank in the industry. Tanks are made in Canature's 925 square foot ISO certified manufacturing facility. This is the world's first and only fully automated pressure tank manufacturing process. Custom-made robots produce consistent, high-quality tanks at the lowest possible cost. Tanks are NSF 44 certified for structural integrity. Over 1 million tanks have been produced without a leak due to a manufacturing defect. The high-density polyethylene liner design has no welds, joints, or seams, eliminating potential leaks. Failure from cracked collars has been 100% eliminated. Tanks come with an unmatched, attractive deep high-gloss finish. Tank sizes range from 5 inches to 63 inches in diameter. Now let's take you to the manufacturing floor and show you how Canature tanks are made.
To begin the process, the concentrated feeder system draws plastic particles into the hopper. The raw material will then enter the extruder. High temperatures produced in the extruder melt the plastic particles. As the robot arm grabs the thread insert, material is checked for quality. If it does not meet specific standards, it will be eliminated in the delivery process. The melted plastic particles are inserted into the open die head mold. Once complete, the robot arm places the thread insert into the blower device, followed by the addition of raw materials. The mold closes and the blow molding begins. During the blowing process, the outline of the tank can be precisely controlled through the control panel. Once complete, the mold opens and the robot arm takes the finished liner and transfers it to a cooling rack. Once cooled, the liner is put on a conveyor belt and is transferred to the liner storage rack. The liner is then placed on the twin roller conveyor. The conveyor belt will transport the liner to the measurement station. At the measuring station, the robot arm automatically grabs the shaft and waits for measuring to begin. During this time, the bottom plate of the shaft will be returned to the designated shaft area. Liners are tested to ensure they pass a standard quality test. Those that are established as qualified will be transferred by the robot arm to the joining station. Those liners that do not meet standards will be discarded into the unqualified area. The qualified liner is then transported to the joining station. Here, the claw will firmly hold the liner while the shaft is screwed in by the motor. If the shaft does not successfully screw into the liner, a sensor emits an alarm, causing the robot arm to remove the tank and place it in the unqualified area. After the shaft is screwed into the liner, a bottom plate must be installed. This process is automatically completed by the bottom plate transporter. If there is any failure in the process, an alarm is sounded, causing the robot arm to remove the liner and place it in the unqualified area. After the successful installation of the bottom plate, the robot arm will transport the tank to the carousel. The loading arm will load tanks onto the carousel until the loading number is reached. At this point, the carousel will automatically rotate 90 degrees into the plasma station, where the surface treatment will begin. During the plasma surface treatment, an inflating process is performed where air is filled into the liner to prepare it for the winding process. The tank is also tested for air leaks during this time. If a leak is found, the robot arm will remove the tank and place it in the unqualified area. After the plasma surface treatment and inflation process are complete, the carousel will automatically rotate 90 degrees where the robot arm will place the tanks onto the winding machine. When the liners are fixed into place, the winding process begins. The winding process automatically controls the following actions: fixed fiber, helical winding, hoop winding, resin volume control, tension control, and fiber cutting. An automatic glue machine works in unison with a winding machine to produce the glue required for the winding process. An automatic fiber break alarm system ensures that any fiber break problems are discovered and fixed in a timely fashion. The completion of the winding process triggers the robot arm to carry the tank to the transport chain. The tank is hung on the transport chain, where it then moves through a solidification process. This process moves the tank through 3 different ovens at varying temperatures. The use of 3 ovens is utilized to achieve a better solidification effect. After the tank exits the oven, the chain will transport the tank to the separation station. Here the robot arm will remove the tank, screw out the shaft, and reload the shaft on the bottom plate. The tank is then placed on the tank storage rack. From the tank storage rack, the tank will then be moved to an automatic packing machine, where the tanks will then be packed.
Thanks for taking the time to watch. Canature sets the industry standard when it comes to continuous innovation, quality standards, and customer value.